Hey guys, welcome to Unit 9, Lesson 1. Our topic is the derivative and rates of change. We are going to be looking into some physics-related material in this unit. So let's get started with the warm-up. The warm-up says the height of a ball thrown upward at a speed of 30 feet per second from a height of 15 feet after t seconds is given by this function. So it's asking us to find the average velocity of the ball for first 2 seconds after it is thrown. So guys, remember, average velocity is same thing as average rate of change of the particle. So this would be what? S of B minus S of A over B minus A. We are looking at the velocity for the first 2 seconds, which means what? From 0 to 2. So it will be what? S of, I'm going to write average velocity. That's what it is. So S of 2 minus S of 0 over 2 minus 0. I'm going to substitute 2 into the function. If I do that, what do I get? I'll get 11. S of 0 will be 15 over 2, which is negative 4 over 2, which is negative 2. What does that negative 2 mean? First of all, we must write down the units. It's negative 2 feet per second. The negative tells you that the ball is coming down. So let's write that down. Tells, because you will be interpreting what these positive and negative signs mean. Negative 2 tells the ball is coming down. Right? Or it's reaching the ground. Whatever you want to call. And remember, the units are very important. I just want to bring that up. It's feet per second. It's the y over the x. We'll talk more about it on the next page. So find the instantaneous velocity of the ball when t equals 2 seconds. Instantaneous means find the derivative and then plug in and plug into it. Right? So that's what you need to think. So I'm going to find S prime of t, which is 30 minus 32 t square t. So S of 2 will be what? 30 minus 32 times 2, which is negative 34. This is also negative, right? So it is also rate. That's why we wrote the unit. It is also rate. So we must label it feet per second, right? So now explain in your own words the meaning of the average rate of change versus the instantaneous rate of change. So the average rate of change is over an interval. So you'll be given a period of time and you calculate it over that. So let's write that down. Average rate of change is over an interval or time, a period of time. And instantaneous rate is at one point, at a singular moment in time, or you can write at a singular moment in time. Oops. Moment in time. Right? So these both are rates of change and they both have the same units, however. But remember, again, instantaneous is happening at a single moment in time and average rate of change is happening over an interval. So let's fill those in. The derivative and rates of change. If f of x represents a quantity, then f prime of x represents the instantaneous rate of change of that function. The derivative gives us a way to talk about how fast anything is changing at a given moment in time. Remember, your instantaneous rate is for that moment of time. But f of x can represent any quantity such as particle position, velocity, area of a circle, outdoor temperature, amount of rainfall, cost of production, etc. Note, the word instantaneous is often used even when x does not represent time, but the word is also often omitted. The units of the derivative of any function y equals f of x will always be y-axis units over x-axis units. Think about it. Isn't derivative a synonym for slope, or slope is the synonym for derivative, right? Which is what? Change in y over change in x. And that's how we write the units. So y-axis units over x-axis units. So that's how you'll determine. Example 1. So in these questions, we are going to be mostly able to interpret the information that's given to us, practice writing explanations, and use the right units. So that's mostly what we're going to be doing for these questions. So this one says the temperature T in degrees Fahrenheit of a cold yam placed in a hot oven is given by, this is the formula given to us, or the equation I would say, where T is the time in minutes since the yam was put in the oven. So part A says, in a complete sentence with units, translate the practical meaning of the equation f of t equals 255. So what does that mean? That's what they're basically asking. So let's first relate to the equation that is given to me. So my equation is, I'm going to write it in the same form, f of t is equal to t, right? So my lowercase t is what? 20 minutes. Lowercase t is time, and uppercase T is temperature, which is 255 degrees Fahrenheit. So now I want to translate this into words is what? At 20 minutes, and what is the context of the question here? The yam and the oven. So at 20 minutes in the oven, right? The cold yam is put in a hot oven. So the yam is at 255 degrees Fahrenheit. So again, what are we looking at? We were looking at the context of the question that it's asking. That was the yam in the oven, and then the lowercase t was 20 minutes. We used the right units for that, and then 255 degrees Fahrenheit for temperature. So part B says, what is the sign of f prime of t and why? So f prime of t would be basically what would be the slope. So we're talking about the temperature, right? So basically whether my slope is increasing or decreasing. So here, if you're putting the cold yam in the hot oven, the temperature is going to be increasing. So what would that be? So basically when it's asking for the sign, is it positive or negative? That's what it's asking. It's going to be positive because the temperature is increasing. Temperature is increasing, right? Increasing. Okay, the next one. It's saying, what are the units of f prime of 20? Remember, what did we say? The units are what? Y-axis units over x-axis units. So what is my y here? It's the temperature, right? So which is degrees Fahrenheit over x-axis is my time, and that's minutes, and that represents my rate. D, in a complete sentence with units, what is the practical meaning of the statement f prime of 20 equals 2? So in my 20 slot, what is it? It's time. So my t is equal to, t is equal to 20, right here. And my derivative is what? 2 degrees Fahrenheit per minute, right? And it is a positive 2. So I'm going to change color. It's positive 2 means what? It's increasing. since it's rate, the sign does matter, because so it's positive here, it means it's increasing. If it was negative, it would be decreasing, right? So now what are we going to write here? So let's write that down. At 20 minutes, and the context of the question is the oven and the yam. In the oven, the temperature of the yam is what? Increasing, because it's positive, at a rate of what? A rate of 2 degrees Fahrenheit per minute. So let's quickly sum up this question. So we want to write in we want to talk about the context of the problem, which in this case was the oven and the yam. You want to do the units for time, which was minutes. You want to do units for your temperature, which was degrees Fahrenheit, and then the positive tells you that it's increasing. So never say decreasing at -2 Fahrenheit per minute or something like that, because when you say decreasing and negative, it kind of negates itself. So if you said decreasing, it should be just 2 degrees or whatever the temperature is decreasing at. Okay, so let's get started with example 2. It's talking about an ice cream company knows that the cost, C in dollars, to produce Q quarts of cookie dough ice cream is a function of the number of quarts they produce. So C equals F of Q. So this is my equation. Now based on this equation, what am I being asked? If F of 200 is equals 70, explain in full sentence with units exactly what this mathematical sentence is telling us in the context of the problem. So again, what's the context of a problem? A context of the problem is Q is the quarts of cookie dough ice cream. So this is Q, right? And 70 is your what? Cost is C. What does that mean? So it's basically telling us that 200, right, quarts of what ice cream is it? Of cookie dough ice cream costs for how many? $70. That's what this mathematical sentence is, right? Again, the context of the problem is here the cookie dough ice cream and the money and the units for each of them. So 200 quarts and $70. Part B. If f prime of 200 equals 3, explain in a full sentence with units exactly what this mathematical sentence is telling us in the context of the problem. So what's in place of 200? So it's in the still Q spot. So my Q is 200, right? And my derivative, or f prime, is, my rate is $3 per quart. So what's happening? At 200 quarts, right? I didn't write quarts here. 200 quarts. The cost is, it's what? Positive, so it's going to be what? Increasing. Increasing. We always need to talk in terms of increasing and decreasing whenever we talk about rate. Cost is increasing at a rate of $3 per quart. So if it was negative, for instance, if it was negative, then I would have been writing the cost is decreasing at that rate. So be very careful with the positive and negative. We need to mention that whenever we talk about rate. We need to mention our slope whenever we talk about the rate. So part C, it's talking about the double derivative. It says if second derivative, or f double prime of 200 equals -0.1, Explain in a full sentence with units exactly what this mathematical sentence is telling us in the context of the problem. So here, look at this. The second derivative, actually, I don't want to talk much about it. The second derivative is your acceleration. The first derivative actually describes how the original function is changing, and the second derivative describes the rate, or describes how my first derivative is changing, right? So it's negative means what? My second derivative is negative means it's what? Decreasing, right? So the rate is decreasing. And the unit for our second derivative is going to be negative $0.1 per quart square. We'll discuss more when we talk about acceleration then. But for now, finish up the remaining of the lesson. For most part, you are writing out what the meaning of these mathematical sentences are. That's what you're doing. There will be some questions that are asking you the average rate of change, which you know is f of b minus f of a over b minus a. And that's basically it. Good luck, guys.